What did we studied in last class?
So we studied about factors on which the resistance of the conductor depends.
Okay. So we also did some. So what was the factors which resistance depends?
R is proportional to length of the conductor. R is proportional of 1 by area of cross section.
Yes, right. So means that if length is increasing, the resistance will be increasing, right?
Yes.
Okay. So actually you are not switching on your videos, okay? So it is some concern or not, whatever is good. So I'm also trying to draw a graph of these two results, okay? This is already, okay, who is now? Okay, hi, Tejasvi.
Hello, sir.
Hi, how are you?
I'm good, sir. How are you?
I'm good. So, do you have any issue in switching on the camera? Tejasvi,
No, sir, but my camera might be a little bit blurry.
no problem.
Okay, sir, I'll switch on my camera.
Okay. Last time one parents came and said that, see, you are teaching and students are just switching off the camera and lying on the couch. So that was parents. So I thought, okay. Okay, no problem. It's quite clear.
Okay, sir.
Okay. So now I think we already studied this relation last time, right?
Yes, sir.
Okay. So now is point to draw a graph. So our relation was R is equal to rho L over A, right? Clear? So question is, draw a graph between R and R and L. Okay. Keeping rho and A constant. Question is clear?
Sir, actually, I wasn't there before few classes.
Okay. So are you aware of this result?
No, sir.
Okay. So can we go 1 minute before Gavita? I should explain her a little bit, right?
Yes, sir.
Okay. So do you know about the resistance? Resistance like that. This is the circuit. Welcome Shreya and Faz. We have to switch on the camera, okay? This is the condition of class. So now it's feel that it's a good class. Otherwise only my camera was on and you guys were. So Faz and Suresh, we have to switch on the cameras. So are you aware of resistance? Tejasvi?
No, sir.
No. So in any electrical circuit, we have bulb, fan, freeze, right? So those bulb, fan, fridge, those are called the resistors. Got the point?
Yes, sir.
You are your bulb is connected over here. If you will see that one bulb, number of wire network in your home, but your mobile or bulb is connected like that. This will be connected in these 2 points. So every load, either is mobile charger, fridge, AC machine, whatever it is load, and that load is being called resistance. Okay, so resistance is basically, it depends on materials. So if you will see that your heater, water heater or geyser, it is made of some filaments that can withheld the high heat. The water heater, they can go to the 80-degree temperature or something, right? On the other hand, in refrigerator, AC, or in refrigerator, they are for to decrease the temperature, right? In these components, we will find the temperature is very less. So material used in air conditioning or in geyser, those are different. We can't use the same. Same as in our mobile phones. The expensive mobile phones uses sometime wire of gold or silver, right? That's why they are expensive. So in the case of a gold wire or copper wire, the resistance is very less. What is resistance? Resistance is usually that opposes the flow of electric current through conductors. Okay, whenever we are using any apparatus through the wire, so you might have seen that the glow of bulb decreases, right? Whenever you switch on the AC, you have seen that glow of bulb decreases. Have you ever noticed it?
No, sir.
So you will try somehow, keep the bulb on and try to switch on 2-3 AC at a time. Okay, so you will feel that. So these are the resistors. So how the resistors depends upon the material, it's already we discussed. So again, we are going back to show you this table. This all machine, because after class I hardly remove the things. I'm so lazy man. So see, silver is expensive material. So it has 10 to the power minus 8 resistivity. It is very less, but when we come to the alloy called tungsten or something, is 10 to the power minus 6. So which one is more, 10 to the power minus 8 or 10 to the power minus 6?
10 to the minus 8.
Okay, 10 to the power minus 8. That's why silver, copper, aluminum, these are being frequently used in our home appliance, right?
Yes, sir.
These alloy have more than that. But see the glass, hard, rubber, ebonite or diamond. So the resistance is order of 10 to the power 14 to 13, 16. So it's tough to flow the current through a glass. Okay, diamond is carbon. Diamond is group of carbon, is not carbon. You have read about in chemistry, right? Have you read about the diamond in chemistry?
Yes.
Okay, so diamond and carbon are the what? The same, in the same category. What we say the name? Carbon is a good conductor of electricity. The dry cell is made up of carbon. A rod that is being used for anode is made up of carbon. Have you seen the torch battery?
Yes, sir.
So carbon is being used there for conductivity. So diamond and carbon is of both of carbon, but it is not conductor. So
Sir,
yeah,
diamond is an allotrope of carbon, right?
yes. Carbon is good conductor, right? Carbon is good conductor, you know that. Do you have pencil?
Yes, sir.
That pencil, what is the made up of that nib? That is made up of carbon. Okay, Shresh, you are most welcome. So that's nib of your pencil. This is the pencil I have. So if you will see now, this nib, this is made up of carbon. Don't try at home, but it is good conductor of electricity. Right? You can design a experiment for your project. I will give you design. Okay. You can do the experiment. You will find. So this is the good conductor of electricity, but diamond is the bad conductor of electricity, but having the same structure. But this has the layers, but the diamond doesn't has the layers. So this is clear. Tejasvi, have you noted it earlier?
Sir, actually, I wasn't there like whole classes. My last class with you was like 2 weeks ago.
So what was the last topic?
Um, just a minute, sir.
Yeah. Suresh, did you study all these things?
Sir, my last topic with you was potential difference.
Potential difference.
Yes,
Oh, so you are too late. So after potential difference,
we did some examples. Example 1.1.
example 11.1. This was the potential difference, right?
Yes, sir.
So we calculated the work done. After that, phase. Okay. After that, we studied about circuit diagrams.
I wasn't there, sir.
Uh, so we studied, we go with the phase, Suresh, we studied about it. So you can take the, what can I say? Can we do later? Okay.
Yes, sir.
You
Yes,
ask the
sir.
admin, okay, and I will summarize all these, okay.
Okay, sir.
So this was the symbols of circuit diagram. Any electric circuit are made up of different components, and those components can be in a standard form written in terms of these symbols, right? So we will be coming to the point where we will see. So after that we studied the Ohm's law. What is Ohm's law? For a given type of materials, potential is directly proportional to the current. We will be using this relation today. V is equal to IR. This relation we will be using today. V is equal to IR. So keep in mind, right? So then we studied the factor which factor on which the resistance depends. So this was the factors we already discussed. So actually resistance depends upon the length of the wire and reciprocal to the cross-sectional area, right? Now I'm going to make you aware of it, how this happens. We did some problem as well on it. So in 1 minute, I will summarize the resistance, how it depends on length. So this is the length of a wire. Suppose it is a copper wire of length L. So as the length will increase, the resistance will increase. How? Suppose we have a battery over here. We just keep a battery and we add the terminal with it. Okay. So now connect a bulb. This is the standard symbol of bulb. And keep a pointer over here, right? It is connected with the battery. If you will connect it over here, so the length is less, so resistance will be less. Okay, so if resistance is less, means that it will glow in the better way. As you will release this contact from here to here, from here to here, as the resistance will increase, then glow of current will
Be
decrease.
more.
V is equal to IR, right? So as the R will increase, the potential will drop. So if potential drops, the bulb will less glow, right? So this is
Yes.
the case. This is the case for length. We also see that when we have to use the wire, if we are using wire for the AC machine, so we take the thick wire, right?
Yes, sir.
But when we have to just keep in the mobile charger, so this is mobile charger. This is a thin wire with respect to AC machine or some heavy machine. Why does it happens? See, this headphone is very thick wire, thin wire, but laptop charger is thick. Laptop charger wire is thick. Have you ever thought why it is happening?
Because the big laptop charger in AC condition needs more power than the phone charger.
Yes. Yes. Okay. So if the wire is more thick, okay, so loss resistance is less. If area of cross section is more, resistance will be less, right? If area of cross section is more, means wire is more thicker. So cross section is more, A is more, R will be less, right? R will be less means there will be less opposed to the flow of current. So we will get good amount of power for that circuit. Clear?
Yes, sir.
Okay. So these are the factor which depends upon the value of resistance. So my point is now I am going to draw a graph. What will be doing? How to draw the graph. So question is already pasted there. Pasted, not written. So question is, we have to draw a graph. Okay, Suresh and Faz. Faz on the camera. Draw the graph for the given problem. Draw a graph between R and L, keeping rho and A constant. So how we will be doing? That is R is equal to rho L over A, right? We said that rho and A are constant. So it will be modified like R is equal to L. The left things are constant, right? So what is relation between R and L? Which type of relation it is? It is linear relation. It is linear relation. Here we have to write rho comma A R constant, right? So Tejasvi, are you aware of mathematical equation in two variables? Have you studied it?
Yes, sir.
How it look like? Y is equal to AX. It look like that? More general, more familiar is Y is equal to MX. right?
Yes, sir.
So do you feel that this equation is same? R is equal to L. How we will draw the equation for this? Y, this is X. M is the slope, right? So it is like that. Clear? Suresh, it's clear?
Yes, sir.
The linear
Yes, sir.
equation in two variable is like that. So how will be this, how this will be looking like? Govita, if this is R and this is L, so how you will draw the graph?
Straight line.
Yeah, of course it is a straight line. If L is 0, means that resistance will be 0, right? If L is maximum, resistance will be maximum. Clear? So you have to mention over here, because these two conditions, we have oversimplified it. We said that rho and A are constant. Now it's time to draw the another relation. Another relation is draw the graph between R and cross-sectional area A, given that rho and L is constant, are constant. So how it will be looking like? This is R or this is A. Suresh and Faz, how we will draw this graph? This is origin now. So this point is 0, 0, right? So our relation R is like that if I will write 1 over A, right? So how we will draw this graph? If I write it, R is, write it, some constant, K is some constant over A, where K is what? These two constant in terms of rho over L, where K is very careful. We have to be very careful if we are assigning some value, where K is equal to rho into L, right? Otherwise teacher will get confused. So draw this relation. It is same that y is equal to 1 over x type relation, right? You must have drawn the graph to solve these equations. So Govita, 1 over 0 is how much? Just wait. Suresh, 1 over 0 is how much?
0.
0 over 1 is how much?
1.
0 or 1 is always 0, na? How it could be 1?
Yes.
What about this?
1.
How you will divide 1 by 0? We here we are dividing 0 into 1, means that I have nothing. So I'm not dividing it with anyone else. But when we'll say I am dividing 1 with 0, so this is totally different mathematics. Although the concept of division is really thrashed over here. Okay, this is called infinity, not defined. This is not defined. Got the point?
Yes, sir.
1 by 0 is never defined. You have calculator? Do you have calculators?
Yes, sir. I have 1.
So just give the command 1 by 0. Even in the math calculator, they will throw the syntax error. 1 by 0 C.
Cannot divided by 0.
Can't divide by 0.
Yeah, I'm now repeat 0 by 1.
0.
0. So it's clear?
Yes, sir.
So you guys were not aware of this. Okay. So it is not defined. So at this point, our this relation will be not defined. So it will be like that. It will be going to somewhere infinity. Okay. At this point, we can't define at 0. So we want draw it to the 0. Okay. Here we drawn from 0, right? So if R is 0, L is 0. But here it will be like this. As R is in, as L is in, A is increasing, resistance will be decreasing. Got the point?
Yes, sir.
Have you seen this graph in your math class? So actually science is interconnected. Science and mathematics is interconnected. So we have to connect knowledge from one branch to another branch. Then only you will feel the beauty of science. Clear? So if we will draw the relation between R or 1 over A, it will be like that. As the area of cross section will increase, resistance will decrease. Clear? So you may draw these two graphs. Faz and Suresh, if it's clear to you, then good. Otherwise, you may ask.
So, can you please repeat? Excuse me, sir.
Yeah. Are you talking to me?
Yes, sir. Can you please repeat
Which part?
the ones you explained just now?
From here? From here?
Sir, about that.
From here I have to repeat, or from here?
Yes, sir.
Your voice is not clear. So see, if you are talking about this graph, so I told to draw a graph between R and resistance and length, keeping that constant rho and A constant. Okay. So now in this case, this relation R is equal to rho L over A will be like R is directly proportional to L. In this case, R and L has a straight line. Clear? If I will ask you to draw the graph between R and area of cross section, resistance and area of cross section. So we already know the resistance is inversely proportional to area of cross section. So it means that if area of cross section is less, the resistance will be more, and area of cross section is more, resistance will be less. So see, we are increasing the area of cross section along this line. So as the area of cross section increases, the value of resistance is decreasing. Clear? Suresh, it's clear to you? Gobita, is clear to you?
Yes, sir.
Okay. So can we move on now?
Yes, sir.
Okay. So without any delay, I'm going to tell you about the new concept, that is resistance of a system of resistors. So what does it mean? First of all, I would like to ask one question. In our homes, okay, bulb, fridge, fans, these are connected through wires, right? So I will first say you, there's a connection of all these apparatus in our homes is like that. Suppose this is a bulb. Okay, so this is wire coming from supply. Okay, this is bulb. There will be one neutral or earth, right? There will be one earth or neutral, right? To glow a bulb, we need how many wires? To glow a bulb, we need how many wires? At least.
Two.
Tejasvi, how many bulbs wire we need to glow a bulb?
Two.
Two, because it's two terminal device, right? So one supply is coming from the pole and other we have to give through the earth. So now this is the supply, and now as we will connect, the bulb will glow, right? So suppose we have to connect n number of operators. This is bulb, okay, then a fridge. I don't know what the symbol of fridge, so I will write it fridge. Now I have to add a geyser. What is spelling of geyser? Geasura. So here is geyser. Now I have to connect mobile charger. It's a very important thing. If we don't have mobile charger socket, life is incomplete. So this is the earth wire, and this is the supply from pole. So complete a circuit, we have to connect it. Okay. So now we have connected it. This is the coming wire, and this is somehow. And this is the I will act is a battery. It is a battery, right? This is the means of connecting the apparatus in our homes. One end of one gadgets to another end of another gadgets. This is the way, okay? One end of one gadgets to another end of another gadgets, right? This type of combination, if we will further write it, it is like that. R1, this corresponds to this. Then again, end to end, R2, this corresponds to fridge. And this R3, this corresponds to that geyser R3, right? Only three operators I am connecting. And what we will do, we will replicate the source or supply with a battery, right? Clear? This combination is clear? This is called the series combination, right? This is called series combination. SERIES, series combination. So series combination is like when we connect one apparatus to the another apparatus end by end, right? So in our household, the operators are not connected in a series. It is connected as in parallel form. How is the parallel form? So parallel is that this is battery. This is battery, right? We are sorry, how this is happening. We are connecting one apparatus like that, and another apparatus we are connecting again through these two terminals of battery, right? And again we have to connect another. We will connect like this. This will be load 1. This will be load 2, resistor 2, resistor 3. This is just stacking on one another. This is called the parallel combination. Parallel combination. Clear? This is basically used in our home as well. Home electric connection. Right? In our
Yes.
home, we use parallel combination. And what is parallel combination? It is a stack over one another. What is benefit of parallel or series? Just write it down, then we will come back. In battery, we make one hand larger than another, right? These two hands are not of equal height. So keep in mind. Have you seen the twinkle light in on the marriage ceremony or somewhere? Or on the Christmas tree?
Yes, sir.
Okay, so how that twinkling wire is connected? In series or in parallel?
In series.
No, that's are connected in series. Maybe the technology improving. So when one bulb get damaged, all the bulb stop working. This happens? No. Gavita, you have already decorated the that Christmas tree.
Yes, sir.
So you never actually you didn't get time that bulb get fused. If in series, if the combination is in series, okay, in this type. So if one resistor or load or one bulb, if it is getting fused, the current will not go through all the wires. Okay. The current will always pass from the larger hands. Direction of current will be like this. If this battery is of P potential. So current will flow like this. So what will happen if we will measure current over here in this segment? If it is I, if we will measure over here, it will be again I. If I will measure over here, it will be I. If I will measure over here, it will be I. So in series, first characteristic is that current remains same throughout the throughout the circuit. Anywhere, if you will measure the current, you will find the same current, right? Clear? No doubt? Faz and whatever the another guy, if your camera is off, I don't know what you are doing. You are studying or you are just sleeping. I don't have any idea. So how we will find the, okay. Then second point is that if we will connect one load over here, so there will be potential drops. This bulb will consume some energy, right? So energy is what? That's in another way, there will be potential drops. So here will be potential drop. Let me make some space. It's so dirty. Let me redraw this. Current will flow through this direction. This battery has potential V. This resistance is R1. This is R2. This is R3, right? So current is flowing in this way. So here will be potential drop across this will be V1. Here will be V2. Here will be V3. So current remains same, but potential will be V1 plus V2 plus V3. This will be equal to this current. Sorry, this potential V. The potential drop across each resistors will sum up to V, to total potential of the battery, right? This is clear. If we will connect a voltmeter here or here, voltmeter at these 2 points, as 2 points. So we will get this V. Clear? If we will connect a voltmeter across this point, we will get the V1. If we are connecting across this point, we will get V2. If we are connecting around this point, we will get V3. So these are the potential drop across these connections, these points, knobs. Clear? So sum of all the potential will be equal to the total potential of the battery. If we are aware of this, we can find the resistance. So what is Ohm's law? What is Ohm's law? OHM is Ohm's law. That V is potential difference is equal to current time resistance, right? This is Ohm's law. Tejasvi, it's clear. Your face color is changing.
No, sir, it's clear.
Okay, so this is the basic Ohm's law. So what will happen? The potential drop this across this V1 will be the current is going through. The current is not changing. Current is remaining same. So it will be I R1, right? Similarly, across the V2 will be I R2. Because current is not changing. Whatever the value of current is circuit at one point, it remains equal at each and every point. Okay. So similarly from V3 is equal to I R3, right? This is clear. So if this is the potential drop across each resistance, so we already know that resistance potential between this and this point is V, right? So potential drop across V will be what? The total current of the circuit and the total resistance of the circuit, right? This is clear?
Yes, sir.
So write this line. First write this statement, then write this statement. Then we will move further. After this line, you have to write it according to Ohm law or from Ohm's law. From Ohm's law. After this, okay. What I will do now? We will take I common. Take current common. Take current common. Can you proceed this? Can you solve this line? Govita and Tejasvi, can you solve this line? Take the I common. How it will be, how it will look like? Can you take I common from this equation? Can we take I common from this red arrow? What? What happened? Just take the common. If I'll take I common, then it will be R1 plus R2 plus R3, right? This is equal to I times R. Is this clear?
Yes, sir.
Yes, sir.
So what is this? If this I is common at this side, if this I is this I and this I is same. Clear? This I and this I is same because I doesn't change. So it is just being cancelled from both sides of the equation. So this will be R1 plus R2 plus R3, and this will be equal to R resultant, yeah, R total. This is our results. Is clear to everyone?
Yes, sir.
Okay. So
Yes.
as it is true for 3 resistors, it is true for infinite number of resistors. Okay. If we have 100 resistors connected in series, if someone is asking you to find the resistance, we will just add up to the 100. If there is 1000 resistors connected in a series and you have to calculate the resultant, you will just add R1, R2, 200 or 1000, whatever. It is true for n number of resistance. it is true for any number of resistors. Clear? Any doubt?
No, sir.
Okay, so what does it means? It means that uh, this is 10 ohm. What is unit of resistor? It is your ohm. So this is 10 ohm. This is 5 ohm. This is 25 ohm. And this is 30 ohm. It is being connected with a battery. And current is flowing through this direction. So calculate the this is V and this is I. Calculate the total resistance. Calculate the total resistance. Faz, do it.
Seven.
How much?
70.
7?
70.
70. Or you are saying 70? What about Tejasvi and Faz?
We're calculating.
Okay.
So we have to add, right?
Yes, right. We have this relation. We have this relation. We have to just sum it. Are you confused in summing?
No, sir. Like 7.
Faz, what is your answer?
70, sir.
Yeah, of course. 70? So what we will do, we will just add all the resistance. Do we have a space? Yes, we have a space. So R total will be just 10 ohm plus 5 ohm plus 25 ohm, 30 ohm. So it is 70 ohm. Right. So in this case, we see that resistance is being increased. So as the resistance is increased, the flow of current will be, it will oppose the flow of current. As much as component you are adding, the flow of current will be decreasing. So if you add n number of bulb in series, so if first bulb is glowing little more, second will be less than that, and the last 100 bulb will be like, it is just something. You won't find any light from there. Okay. Okay, so this concept is understood by each and everyone, no doubt. So now this is the question for you. An electric lamp whose resistance is 20 ohm and a conductor of 4 ohm resistance are connected to a 6 ohm battery. I won't show the figure. Calculate the total resistance of the circuit, and B, the current through the circuit. C, the potential difference across electric lamp and the conductor. Sorry. This is the figure. Did you get Faz?
Yes, ma'am. I got the A and B.
Okay. So actually, new student started to come inside the class. So tell me, what is the answer for A?
24 ohm.
24 ohm. This is 4 and this is 20 ohm, right? So we'll just add 20 plus 4 is 24. 20 plus 4. This will be 24. What about the B? Ohm's law, we have to use Ohm's law. Ohm's law. That V is equal to I times R. So we already know V is 6. I will be V over R. So V we have 6 and R we have 24.
0.25
This is the answer
ampere.
for the B, right? Everyone?
Yes, sir.
It is
0.25
B.
ampere.
This is for the B, right? 6 1 the 6, 6 4 the 24. So this will be 1 over 4, 10.25. Like that, 1 by 4. So I will write it over here. Then okay. The C is the potential difference across the electric lamp and the conductor C. Again, we have to use Ohm's law. Ohm's law. V is equal to I times R, right? So for bulb,
0.25 into 20.
okay, yeah, right. So for bulb, V is equal to I times R. So I is 0.25 into R is 20, right?
Yes, sir.
So instead of writing this, we may write is 1 over 4 into 25. Right, 4 5s are 20. No, it's not going to cancel. So 6 point something. Like that. 6 4s are 24. So it will be like that. And for conductor, we will be I times R. So I is again 0.25 and R is 4. So this will be
1 volt.
1. This is volt. And what about the, this is ampere. Okay, this is ampere, AMPM. So now this is ohm. Clear? Any doubt from this class?
No, sir.
No, sir.
There are n number of doubts. When you will come into the practice, you will feel okay. So I think it was bit mathematical.